This is a demo for identifying the underutilized EC2 instances and stopping them that helps in lowering the cost of AWS bill. Here we can see that already 3 EC2 instances are up and running. And this is the Python script for finding out the underutilized EC2 instances. So let's run the script. Here we can see that the script has started running. In this script, the EC2 instance is considered to be underutilized when the following criteria is met. That is, if the CPU utilization is less than 2% in a day and the network IO is less than approximately 0.05 GB, then it is considered to be underutilized. It loops through all the region of the AWS and fetches the metrics from the CloudWatch for CPU utilization and the network IO of each instances and compares it with the minimum value that is set. If the utilization is less than the threshold value, it stops the instances as the instance is considered to be idle. Also, the script creates a CSV file output that contains the details of each instances. Here we can see that ec2.csv file is created. So in this CSV file, we can see the detail of each EC2 instance, that is the region of it, the instance ID, the CPU utilization of it, the network input output of it, and the minimum value set for it. And then finally, we can see the state of the instances, if it is idle or not. Here we can see that there are 3 idle EC2 instances. So hence, when we refresh this AWS page, we can see that all 3 idle instances will stop running. This is a demo for identifying the unattached EBS volumes and taking a snapshot of it before deleting it. It is necessary to delete the unattached EBS volumes as it contributes to the AWS cost. Here we can see the EBS volumes created, and here 3 of the EBS volumes are in use and 1 is unattached to any of the EC2 instances. This is the Python script to find the unattached EBS volume and taking snapshot of it before deleting it. So let's run the script. The script has started running. In this Python script, it loops through all the region of the AWS and finds out the detail of all the EBS volume. It creates a CSV file, that is report.csv file, as output that will give the details of each EBS volumes in it with its volume ID, its state, if it is in use or just available, and also the number of attachment it has. If the attachment is 0 and the state of it is available, it means that the volume is not attached to any of the EC2 instance. Hence, that particular instance has to be deleted, but a snapshot should be taken before deleting it as a backup for the disaster recovery. Here we can see that report.csv file is generated. Here we will have the detail of each EBS volume with its region, its volume ID, its state, its attachments. Its state is if it is in use or if it is available. If it is available, that means that it is unattached. Also, it gives another CSV file as an output that contains the detail of the volume ID that was deleted and its snapshot ID. That is this file. Since one of the EBS file was unattached, it gives the detail of its volume ID and its snapshot ID for the further recovery of it. Here, if we reload this AWS page, we can see that this particular unattached EBS volume which was there will be deleted for now, and also a snapshot of it will be created.
So this is a quick demo of working of certain services that we have tried to optimize in AWS using our Boto 3. This is just a small pipeline for running the scripts according to the user's input. Starting off the ideal RDS instances, it fetches the metrics using CloudWatch, that such as date, time, and database connection. Z is the number of connections a database has, and if it's greater than 0, then the database is not ideal, else the database considers idle. As you can see here, the database is initially available, and after running the scripts, if I refresh this page, the database is stopped. Coming to the next module, unassociated elastic IP. So this detects if the IP is associated with an EC2 instance or not in every region. This fetches the metrics using CloudWatch, and Boto3. So it checks for the address if an instance ID has an address or not. As you can see here in Elastic IP, one of the IP I've allocated to one of the instances, and one IP has no instance allocated to it. So the output of this particular script is in a CSV format, which detects the region and the address which is unassociated. Third module is the underutilized EBS volumes. This detects based on the input output per second, which network input output per second, that helps us to see which volumes are underutilized. So I've set a threshold as a larger value, so that if it exceeds this value, then the volumes are not underutilized. Else the volume is underutilized. It prints back into the CSV file after checking through all the regions. This output is in a CSV format, underutilized volumes, that is volume 1, 2, 3, 4, which has been allocated. If you check here, and all the input output second are less than 7, this value is set only for the testing purpose. Coming to the fourth script, that is the legacy instances. Basically, this checks if the instance is in the current generation or it requires any recommendation for a better configuration. So this is if the user is not in the latest version, the CSV file shows the recommendation of if the user has to move to a better configuration of the instances. Since T2 Micro is a very small version, it suggests the user to change to a better configuration for all the volumes or instances which has been created in AWS.
This is a demo for RI recommendation. It is a simulation service for driving the cost optimized configuration of AWS EC2 instances using reserved instances. We take an input of expected usage of EC2 instances as per the below. So the input test CSV file has been taken. So for the platform, there are various platform. For each there is a hourly rate. For each region there is a separate hourly rate too. So these are the pricing policies. We are choosing all upfront as the pricing policy. So the CSV file shows the server types, number of server types, and the number of months as the input. So it shows how many types of EC2 instances are taken, and which month how much the usages are. So for the price information, we take it from the AWS itself. So accordingly, for each platform in each region and for each type, there is a different pricing hours rate. So on-demand prices, no upfront prices, partial upfront prices, all upfront prices. Now, for to see the cost analysis, we click on the job submit. It shows us the cost gain achieved after using the RI algorithm. So while not using the RI algorithm, it shows us this much is the cost usage, and after using the RI algorithm, this is the cost usage. So it depicts the monthly cost. The graphical shows how much is the cost optimization of the thing, and total cost of each server, how much it is reduced. So now it's showing the instance analysis, how much instances are used as per the pricing policies chosen, and how much is this number of instances is used per server type, how much it is reduced, optimized. So now we will choose a different pricing policy and show the difference. So we are choosing a no upfront, where we don't have to pay for it in front, but it's the hourly change difference. So the cost gets reduced as per larger the upfront, greater the discount.